Now let us study about the highway lightning. Many a times when we move around the roads, we always see that there are several lightning facilities provided on the road. The rate of highway accidents and facilities that occur during night driving in several times higher in terms of vehicles kilometer than the during daytime. Many a time we also see that vehicles move very fast during the night time in spite of daytime. Hence light is very important. One of the various cause of increased accident rate during night may be attributed to poor night visibility. Highway lighting is particularly more important at intersections, bridge side, level crossing, and in place where there is restrictions of traffic movement. Right? So, where it is necessary to provide on the intersections, bridge side, level crossing, and in the places where the restrictions to traffic movement is there. Right? The driver feels more comfortable in driving under proper street lighting. Right? Improved visibility at night by means of artificial lighting should be done in order to reduce the strain on driving and ensures comfort. With better lighting, the speed of the traffic generally improves and traffic flow condition also improves. Then on rural roads, lighting on the rural roads have not yet become more common, evidently due to the cost consideration and less number of pedestrians and other slow traffic using the facilities at night. But on the contrary, on urban roads where the density of population is very high, road lighting has other advantage like feeling of security and protection. Thus, even though headlights of vehicles may be sufficient for safe night driving, still road lighting may be considered as an additional facility for the road users. This is very important principle. Then there are several factors which influence the night vision or night visibility. Some amongst them are among the amount and distribution of light flux from the lamps. It is going to get vary. Ultimately, it is going to hamper the lighting facility. The size of the object, brightness of the object, brightness of the background, reflecting characteristics of the pavement surface, glare on the eye of the driver, and time available to see an object are some of the factors which will influence the night visibility. Then there are some terms that we'll study in detail. Luminous flux. This is the radiant power given by the light source. What it is? It is nothing but the radiant power given by the light source. Its SI unit is lumen. Then what is lumen? It is indicated by Lm. It is equal to the amount of flux received on the surface area of 1 square meter of sphere when the light source of one candela power placed at its center. Means how much light it is going to give is nothing but a lumen. SI unit of lumen is luminous flux. Lumen is calculated by candle power into angle at which it is going to throw the light. Steradian. A steradian is the unit of solid angle. It is equal to the solid angle subtended at the center of the sphere by unit area of its surface. You simply remember these terms. Okay. Then luminous intensity. It is the luminous flux emitted per unit solid angle is called as the luminous intensity. Then candela. It is the unit of luminous intensity. Luminous intensity expressed in candelas is called as candle power. Glare. Already this we have learned in detail, but still we'll simply focus on it, overlook on it. Condition of vision in which there is discomfort, or a reduction in the ability to see the significant object, or both, due to an unsuitable distribution of luminous or to extreme contrast in space or time, is called as glare. Then lantern, a house for one or the more lamps comprising a body and reflector, diffuser, or enclosure associated with the lamps is called as lanterns. Then illumination. Illumination is, it is the measure of amount of light flux which falls on the surface. Illumination, we see the lights are on and off. How we say on? If it is throwing the light, then we say it is on. That is nothing but a illumination. So its formula is E is equal to Lm into C suffix U into Lmf upon S into W. Its unit is lux or lumens per square meter. Now what does these terms indicate? Here Lm is equal to lamp in lux, C suffix U is coefficient of utilization, Lmf lamp maintenance factor, this is given in the IS codes. S is spacing between the luminaries and W is the width of the street or roadway in meters. Now next important term we have luminance or brightness. The luminous intensity emitted or reflected per unit area of the surface is called luminous. Whatever is the intensity of the emitted light per unit area is called as a luminance or brightness. Now distribution of light. How exactly the distribution of light occurs? The total output of a point light source will naturally radiate uniformly from the point with equal intensities in all direction. If you lamp a light at one location, ultimately it is going to throw light along all the direction, along all the periphery of that bulb or light. It is evident that such light distribution could be insufficient and uneconomical when the purpose is to direct the light towards a relatively limited area, such as the pavement of the street. If you lamp a light, it is not like that it will only throw the light along the pavement. It is going to throw light along its periphery, right? There are mainly three types of distribution of lights, like glare, vertical distribution of light, and lateral distribution of light. Now what is glare? The distribution influence when viewing a difficult visual task under low brightness condition is known as glare, right? Now see, many a times we see when a vehicle is moving towards you, when it is facing towards you at night, ultimately the lamps of the vehicle will make you to unable to see the object clearly. That is nothing but a glare, right? So what is happening? The distribution is influencing and it becomes a difficult task for you to see under low brightness condition. So there are again two types of glare: disability glare and discomfort glare. Disability means this condition we can see, vehicle condition. Another discomfort means if there are droplets on the suppose if we say there are droplets on the screen of a moving frontier of a car, and if there is a light focused on this frontier, ultimately it will not become for you the visibility, right? That is nothing but a discomfort glare. The amount of glare present depends upon the brightness of the glare source, angle of incidence with respect to the normal line of vision, area of glare source, and distance of glare source from the observer. Now lamps. In one or the other ways, in one or the other use, we have seen all these types of lamps either used for household purpose, or for any commercial uses. The lamps commonly used for highway lightnings are, now these are the lamps which may be generally used for highway lighting purposes. Some are mercury vapor lamps, sodium vapor lamps, fluorescent lamps, and tungsten filament lamps. Then luminary distribution of light. How exactly the distribution of light takes place? To have the best utility of the luminaries or the source of light, it is necessary to have proper distribution of light. It should be aimed to achieve following purposes. It should cover the pavement between the curbs, right? If you're going to lamp a light, ultimately whatever will be the curve area, it should acquire that. It should make prominent the traffic signs and other objects on the road. Whatever light you will be focusing, it should clearly show the traffic signals or whatever will be the signboards which will be providing. It should produce maximum uniformity of the pavement brightness. As we said that distribution of light takes place in three ways, that is glare, horizontal distribution and vertical distribution. So next we have the horizontal distribution or horizontal aiming. When two floodlights is mounted to a single pole, then horizontal aiming also must be considered. Each floodlight should be vertically aimed according to the two-third rules. The floodlights should be aimed up to 90 degrees apart. The distribution of light in the horizontal direction is equally important. It is not enough that the pavement alone is lighted from aesthetic consideration. The pedestrian footpaths and the curbs are also needed to be adequately lighted. Again, this horizontal distribution can be further divided into symmetrical distribution, axial distribution, and non-axial distribution. Now see the figures on the top. What does it shows? It shows you the types of horizontal distribution of the light. Now see, if you mark the light on the pole at one place, ultimately it is going to focus on the entire area. Okay, this center is the luminary light source. Then second figure shows you, if you give two lamps at 270 apart, ultimately it is going to throw light to some extent only to 25 degrees on both the side. Okay, this is important, right? See, if the two lateral distribution for narrow roads, again asymmetrical distribution is there. Then medium width asymmetric lateral distribution for roads with medium width, and wide asymmetrical lateral distribution for very wide angle. Means if you give the lamp on at the center on both the side, two lamps on either side, and if the angle is 45 degree, they will provide the distribution at 45 degree angle, right? It will give you a wide spread. Then for fourth, wide asymmetrical lateral distribution, again it is for wide highways. Mostly in a wide highways you also have to provide it on the wider areas. So figure number 4 covers the more area, whereas for fifth, normal asymmetrical distribution for mounting at center of the highways and at intersections. See, generally at intersections we see that entire circle is covered by these lights, hence this type of mounting should be done. Figure number 5. So depending upon the type of requirement of the light, these lamps are, this luminary distribution is followed and the lamps are installed. Now third type is vertical aiming or vertical distribution of the lights. The vertical distribution of light in street light system follows one of the three types: cutoff, In cutoff system, the light is reduced as completely and as rapidly as possible about a 70-degree angle with the downward vertical. The main beam usually at this angle is provided. This system eliminates the glare. In vertical aiming, what happens is this, whatever the lamp will be there, right, it will be focused at an angle of 70-degree. Okay, then what happen, it will cover a widespread area. The non-cutoff high angle beam. In non-cutoff high angle beam system, the peak intensity is at about 80-degree and there is considerable output near the horizontal plane. With this system, a certain amount of glare is inevitable and the modern lighting practice does not favor this system. Hence, this system is not widely in use. And third one, semi-cutoff, that is medium angle beam. The non-cutoff medium angle beam system is in between above two system with a peak intensity directed at an angle of 75-degree angle. Now there are some design factors for lighting like contrast. When the brightness of the object is less than that of the background, then that is when the object appears darker than the road surface. Discernment is principally by Silthouse. Height and overhang of mounting. The glare on eyes from the mounted lights decreases with increasing the height of the mounting. This is important factor. See, the glare on the eyes from the mounted light decreases with the increase in the height of the mounting. The light will not directly affect your eye by increasing the height of the lightning. By increasing the height, ultimately the widespread area will also go on increasing. Usually mounting height ranges from 6 meter to 10 meter. When once you pass along the road in the urban areas, you see there are various types of lighting provided along the streets. Overhangs on the lightning poles would keep the poles away from the pavement edges but still allows the lamp to be held above the curb or towards the pavement. So here are again some figures shown, various types of various types of lighting facilities. The lightning pole should not be installed very closely to the pavement edge because in that case the capacity of the roadway is increased and the free movement of traffic is obstructed. So ultimately there should be some spacing, proper spacing provided between the lightning. We'll study it in detail. As per IRC, the horizontal clearance for the lightning pole for roads with raised curbs, it should be minimum 0.3 meter to 0.6 meter from the edges of the raised curb. Okay, and for roads without raised curbs, that is curbs are provided along the road itself, they are not raised, by providing certain height, by providing certain islands. The minimum is 1.5 meter from the edge of the carriageway, subject to 5 meter from the center line of the carriageway. These are the specification by IRC. So these are some of the figures showing you the lightning layout on the horizontal road, showing the spacing. Second figure is effect of mounting height of overhang on length of the shadow. Means if the vehicle is parked and if there is a pole, the shadow should fall at a certain place that it should not affect the movement of the another vehicle. Overhanging should also be avoided and proper location of the lamp should be done in order to counteract the shadow problem. Now again in this vertical aiming, the fixture should be aimed to two-thirds of the distance across the area to be lightened and at least 30-degree angle should be provided below horizontal. Then mounting height. Mounting height should be one half the distance across the area to be lighted. If the area to be lighted is 16 meter, the lowest recommended mounting height is 8 meter. Mounting height is half the distance to be lighted. Whatever area you want to cover, the height should be simply doubled, or we can say height should be equal to half the distance to be lighted. Then spacing. The spacing between lamps and the street roads is about 3 to 5 times the mounting height. The spacing between lamps on straight road is about 3 to 5 times the mounting height. How much it should be? 3 to 5 times the height spacing. For sharp curves, the spacing between the lamp will go on reducing, or it will be as close as possible for better visibility condition. Okay, so this figure, fourth figure, is showing you the lighting facilities on the curve. Okay, now see the spacing between the lamps is going on decreasing, whereas for the simply straight roads, the spacing should be around 3 to 5 times the mounting height. When more than one luminar per pole is required, then the distance between two adjacent luminars per pole is 4 times mounting height of luminars per pole. If the mounting height of the luminar per pole is 8 meter, then the distance between adjacent luminar is 32 meter, 8 into 4. Then pole spacing should be 4 into mounting height. So depending upon the how much should be the pole spacing, 4 into mounting height. Now this is the graph showing the spacing. Spacing is lamp lumen into coefficient of utilization into maintenance factor upon average lux into width of the road. This is nothing but then what is the coefficient of utilization? It is nothing but the ratio of width of area upon mounting height. Simply we can say coefficient of utilization is nothing but a width of area upon mounting height, and it is obtained from this above figure. The maintenance factor takes into account the decrease in efficiency of the lamp with age. An average value of about 80% can be assumed. Then lighting layout. When once you move along the streets, you might have seen these figures like this lighting facilities are provided. This is nothing but the layouts adopted for lighting poles on streets or highways. This can either be single-sided lighting system, only one-sided lighting is provided. See these figures. Whereas both side lamp system, the figure number 1, both side lighting staggered, means either side it can also be provided, and central lighting system, again the first figure. Then what are the benefits of this lighting? Due to proper street lighting, the police can do better patrol during night, and their job becomes easier and more manageable. The architects and town planners have found lighting to be major source for beautification of their projects. Increase in business in cities or town during night, which could otherwise have a totally deserted. Due to good street lighting, there is considerable reduction in accidents during the night. The illegal actions and antisocial activities on the roads are certainly discouraged by the improved lighting techniques, and it gives pleasure atmosphere during the night hours. So with this, we have completed our entire syllabus of unit number 3, and also I have referred this some of the textbooks for this. Kindly refer Justo and Khanna book of highway engineering. Entire syllabus is given in very neat and easiest simplest language. You kindly refer, it is a proper reference book. So thank you. If you have any doubts, you are always welcome. You can ask me anytime. So thank you very much.